Hey folks, Mr. Dell here. We are looking at a question that has probability as our concept. And this one is coming from, and this is compound probability, where you have a couple events occurring, right? So this is a problem from CPM's course 2, and this is section 5.3.2, number 5-10. So 110. So it says the spinner below is spun twice. So I have this spinner, right? And I'm spinning it twice, right? I spin, 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 and it's going to spin twice. Make a table and calculate the probability of each of the following outcomes. So it wants the probability of getting black twice, and it wants the probability of getting green twice, right? So if I have a table already set up for me, right? This is my table that I'm gonna make. I'm gonna make a table. If you don't have one already set up, you can make a table very similar because each one is represents a different thing. So this right here would be, say, my spin number 1. And then this right here, these would be my spin number 2. So on my first spin, I get purple. On my second spin, I get purple. So that would be purple, purple. This one, I said I got my first spin to be green. My second spin was purple. So that would be green, purple. On this first spin, I get black. On my second spin, I get purple. So that would be black, purple, right? So this is a combination of the two spins. If it was first spin purple, second spin green, that would be purple, green. First spin purple, second spin black, that would be purple, black. Then green, green. Then black, green. And then this would be green, black, and black, black. Okay, so those are the combinations I have. So if I think about probability here, I'm looking at A, I'm doing that one first. It wants to know what's the probability, and this is how we write it, probability of black twice, right? So probability, remember, is always what? I'm going to write it up here. So remember, probability is always, as a fraction, it's always your desired outcome over the total possible outcomes. Okay. That's probability, two numbers. Probability is always two numbers: desired outcome over total possible outcomes. So my desired outcome was black twice. Well, how many times did I get black twice? Once. So it's 1 out of how many total possible is 9. So black twice is 1 out of 9. Okay. So if I think about the same thing with green, so for this one, for B, so that's A. So for B, it's the probability of green twice. Well, again, look at how many times do I get green, green? I get it once. So it's 1 out of all the possible is 9. Okay. So if you were going to build a table, but I also want to make sure you understand if you're dealing with the probability of two events, right? In this case, I'm going to talk about green, green here. If I said I want the probability of getting green and green, right? That means green twice. The probability of one event and another event. So green on the first and green on the second. So when you look at this, it's really what you're doing is you need to find the probability of green and you multiply it by the probability of green, like each of the separate ones. So that would be what? If on my first spin, what is the probability of getting green? Well, the first spin, the probability is 1 out of 3. On the second spin, what's the probability of getting green? It's still 1 out of 3. So really 1 out of 3 times 1 out of 3, or 1/3 times 1/3, is 1/9. And that's another way of looking at it. You didn't need to have the table. We could have just talked about each event separately. The probability of getting green is 1/3. The probability of getting green, again, is 1/3. And you multiply those to talk about the compound probability, which in this case is 1/9. So that's a couple ways of thinking about this problem. Okay.